Section 2, The Basics. In this section, we will learn the following topics: Basics of Cloud Computing, AWS Global Infrastructure, Ways to access the AWS Cloud, Video 2.1, Basics of Cloud Computing. In this video, we will cover the following topics: What is cloud computing? The 6 advantages of cloud computing, types of cloud computing service models, that is IaaS, PaaS, SaaS, types of cloud computing deployment models, that is public, on-premise, hybrid. What is AWS Cloud? To get started, let us first ask, what is cloud? Cloud is not something that you can't see or touch. It's physical hardware that is far away from us but can be accessed over the internet for computing. So, the cloud refers to servers or storage devices that are accessed over the internet to run software and databases on them. Also, cloud enables us to access the same files and applications from many devices because the computing and storage take place in data centers instead of in local devices. Now let us come to cloud computing. Cloud computing, to be precise, is a network of remote servers that are hosted on the internet to manage, process, and store data rather than our local server or a personal computer. Okay, now you may ask, how does this computing over the internet happen and how does it work? This is possible because of virtualization. So now, what is virtualization? Virtualization allows us to create a simulated, digital-only virtual computer that behaves as if it were a physical computer with its own hardware. It is technically a virtual machine. When properly implemented, virtual machines on the same host machine are sandboxed from one another so they don't interact with each other. The files and applications aren't visible from one virtual machine to the other virtual machines, even though they are on the same physical machine. Through cloud computing, companies or persons can rent access to anything from storage to applications rather than owning their computing infrastructure or data centers from a cloud service provider. And basically, this cloud service provider is someone who manages the data centers where the actual hardware exists and makes them available to us. Okay, now let us come to the advantages of cloud computing. Trade CAPEX for OPEX. With cloud, you can pay only when you consume computing resources and pay only for how much you consume instead of investing heavily in data centers and servers upfront. With cloud, you eliminate all the capital expenditure that comes with IT infrastructure and convert them into operating expenses. Benefit from massive economies of scale. By using cloud computing, you can achieve a lower per unit variable cost. How so? This is because usage from hundreds of thousands of customers is aggregated in the cloud, on account of which providers such as AWS achieve very high economies of scale, which they pass on to you as lower pay-as-you-go prices. Stop guessing capacity. By using cloud computing, you eliminate guessing on your infrastructure capacity needs. When we make a capacity decision before deploying an application, we often end up either sitting on expensive idle resources or dealing with limited capacity. With cloud computing, these problems go away. We can access the resources exactly as per our requirements with only a few minutes' notice. Increase speed and agility. In the cloud computing environment, new IT resources are only a click away, which means that we reduce the time to make those resources available to our developers from weeks to just minutes. This results in a high increase in agility for the organization. Stop spending money running and maintaining data centers. We can focus on projects that differentiate our business, not the infrastructure. Cloud computing lets us focus on our own customers rather than on maintaining servers. Go global in minutes. With cloud computing, we easily deploy our application in multiple regions worldwide with just a few clicks. This means we can provide lower latency and a better experience for your customers at a minimal cost. After knowing these advantages, you may be inclined to ask, how are we going to use this? What exactly does a cloud service provider provide us? Then let's jump into types of cloud computing services. Mainly, there are 3 different types of cloud computing services: IaaS, PaaS, SaaS. Take a look at this and see if you can figure out these three levels of services. Let us now learn about these in detail. IaaS is a short name for Infrastructure as Service. In this model, a company rents the servers and storage they need from a cloud provider. They then use that cloud infrastructure to build their applications. We can view it as a company leasing a plot of land on which they can build whatever they want, but they need to provide their own building equipment and materials. AWS, GCP or Google Cloud Platform, and Microsoft Azure come into this category. PaaS is a short name for Platform as Service. In this model, companies pay for the things they need to build their own applications. PaaS vendors offer everything necessary for building an application, including development tools, infrastructure, and operating systems over the internet. PaaS can be compared to renting all the tools and equipment necessary for building a house, along with a plot of land, rather than only land as in IaaS. AWS Elastic Beanstalk, Heroku, Google App Engine, etc. come into this category. SaaS is a short name for Software as Service. Here, users, instead of installing an application on their device, SaaS applications are hosted on cloud servers and users access them over the internet. SaaS is like renting a house. The landlord maintains the house, but the tenant mostly uses it as if they owned it. Gmail, Salesforce, Office 365 come under this category. In IaaS, only servers, storage, and networking are managed by cloud service providers. OS, runtime, data, applications are to be maintained by you. In PaaS, servers, storage, and networking OS, runtime are managed by cloud service providers. Data, applications are to be managed by you. In SaaS, servers, storage, and networking OS, runtime data, applications, all of them are managed by cloud service providers. When to use IaaS? Startups and small companies may prefer IaaS to avoid spending time and money on purchasing and creating hardware and software. Larger companies may prefer to retain complete control over their applications and infrastructure, but they want to purchase only what they actually consume or need. Companies experiencing rapid growth like the scalability of IaaS, and they can change out specific hardware and software easily as their needs evolve. Anytime you are unsure of a new application's demands, IaaS offers plenty of flexibility and scalability. IaaS limitations and concerns. Security. While the customer is in control of the apps, data, middleware, and the OS platform, security threats can still be sourced from the host or other virtual machines or VMs. Legacy systems operating in the cloud. While customers can run legacy apps in the cloud, the infrastructure may not be designed to deliver specific controls to secure the legacy apps. Internal resources and training. Additional resources and training may be required for the workforce to learn how to effectively manage the infrastructure. Multi-tenant security. Since the hardware resources are dynamically allocated across users as made available, the vendor is required to ensure that other customers cannot access data deposited to storage assets by previous customers. When to use PaaS? Utilizing PaaS is beneficial, sometimes even necessary, in several situations. For example, PaaS can streamline workflows when multiple developers are working on the same development project. If other vendors must be included, PaaS can provide great speed and flexibility to the entire process. PaaS is particularly beneficial if you need to create customized applications. This cloud service can also greatly reduce costs, and it can simplify some challenges that come up if you are rapidly developing or deploying an app. PaaS limitations and concerns. Data security. Organizations can run their own apps and services using PaaS solutions, but the data residing in third-party, vendor-controlled cloud servers poses security risks and concerns. Integrations. The complexity of connecting the data stored within an on-site data center or off-premise cloud is increased, which may affect Which apps and services can be adopted with the PaaS offering? Vendor lock-in. Business and technical requirements that drive decisions for a specific PaaS solution may not apply in the future. If the vendor has not provisioned convenient migration policies, switching to alternative PaaS options may not be possible without affecting the business. Runtime issues. PaaS solutions may not be optimized for the language and frameworks of your choice. Specific framework versions may not be available or perform optimally with the PaaS service. Operational limitation. Customized cloud operations with management automation workflows may not apply to PaaS solutions as the platform tends to limit operational capabilities for end users. When to use SaaS? SaaS may be the most beneficial option in several situations as following. Startups or small companies that need to launch e-commerce quickly and don't have the time for server issues or software. Short-term projects that require quick, easy, and affordable collaboration. Applications that aren't needed too often. Applications that need both web and mobile access. SaaS limitations and concerns. Vendor lock-in. Vendors may make it easy to join a service and difficult to get out of it. For instance, the data may not be portable technically or cost-effectively across SaaS apps from other vendors without incurring significant cost or in-house engineering rework. Lack of integration support. Many organizations require deep integrations with on-premise apps, data, and services. The SaaS vendor may offer limited support in this regard, forcing organizations to invest internal resources in designing and managing integrations. Data security. Large volumes of data may have to be exchanged to the back-end data centers of SaaS apps in order to perform the necessary software functionality. Transferring sensitive business information to public cloud-based SaaS service may result in compromised security. Customization. SaaS apps offer minimal customization capabilities. Since a one-size-fits-all solution does not exist, users may be limited to specific functionality, performance, and integrations as offered by the vendor. Lack of control. SaaS solutions involve handing control over to the third-party service provider. These controls are not limited to the software in terms of the version, updates, or appearance, but also the data and governance. Feature limitations. Since SaaS apps often come in a standardized form, the choice of features may be a compromising trade-off against security, cost, performance, or other organizational policies. Performance and downtime. Because the vendor controls and manages the SaaS service, your customers now depend on vendors to maintain the service's security and performance. Planned and unplanned maintenance, cyber attacks, or network issues may impact the performance of the SaaS app despite adequate service level agreement or SLA protections in place. Each cloud model offers specific features and functionalities, and it is crucial for you to understand the differences. Whether you need cloud-based software for storage options, a smooth platform that allows you to create customized applications, or complete control over your entire infrastructure without having to physically maintain it, there is a cloud service for you. Okay, we understood different types of cloud computing services with their unique benefits and their trade-offs in terms of flexibility. But how do we deploy these? As you already know, different customers will have different requirements, right? To figure this out, we need to understand the cloud deployment models. The cloud deployment models represent the specific category of cloud environment based on ownership, size, and access, and describes the nature and purpose of the cloud from the user's perspective. The different types of cloud deployment models are the public cloud, the private cloud, and the hybrid cloud. Public cloud, that is cloud in AWS. The public cloud is a type of cloud hosting that allows the accessibility of systems and its services to its users easily using cloud computing. Amazon, Microsoft, IBM, Google, etc. are some of the biggest public cloud providers. This cloud service is open for use and fully utilizes cloud computing. This type of cloud is economical as there is a decrease in capital overheads on account of economy of scale. Startups, SaaS offerings, new companies, and projects can easily use this to improve their business. Private cloud, that is on-premise in AWS. Private cloud, also termed as internal cloud or on-premise, allows the accessibility of systems and services within a specific boundary or an organization. The private cloud platform is implemented in a cloud-based secure environment that is guarded by advanced firewalls under the surveillance of the IT department that belongs to a particular organization. Private clouds permit only authorized users, providing the organizations greater control over data and its security. Business organizations that have dynamic, critical, secured, management demand-based requirements typically adopt private cloud. Public sector organizations with super sensitive data such as hospitals, large enterprises with heavy regulations such as insurance companies are some of the classic users of the private cloud. From the technical point of view, there is very little difference between private clouds and public clouds along with the structural design. Only the security and privacy levels are higher for private cloud as against the public cloud. However, the public cloud is better suited for business purposes when it comes to managing the load variations. Hybrid cloud. Hybrid cloud is a cloud computing type which is integrated, that is, it is a combination of two or more cloud servers, private or public combined as one architecture, but that remain as individual entities. Non-critical tasks such as development and test workloads are done using a public cloud. In contrast, critical functions that are sensitive, such as certain types of data handling and storage, are done using a private cloud. Thus, the hybrid cloud model enjoys the benefits of both public as well as private cloud. Banks, investment management companies, and insurance companies are typical users of the hybrid cloud model. Now we come to AWS. To get started into AWS, let us first ask, what is AWS Cloud? Amazon Web Services or AWS Cloud helps businesses scale and grow by providing a secure cloud services platform offering to compute power, database, storage, content delivery, and other functionality that we have discussed previously. In simple words, AWS allows you to do the following things among other things. Allowing to host dynamic websites by running web and application servers in the cloud, securely storing all your files on the cloud so you can access them from anywhere, using managed databases like MySQL, PostgreSQL, Oracle, or SQL Server to store information, delivering static and dynamic files quickly around the world using a content delivery network or CDN, sending bulk emails to your customers. Summary. In this video, we have covered the following topics. What is cloud computing? The 6 advantages of cloud computing, types of cloud computing service models or IaaS, PaaS, SaaS, types of cloud computing deployment models, that is public, on-premise, hybrid. What is AWS Cloud? In the next video, we will learn about AWS Global Infrastructure.